I have some integral challenge here. So I want to see how fast I can go on solving this question, okay? So also at the same time, I want to make sure that you get to understand, because some of you here, they might be new, so you don't understand how integral works. So I'll make sure that I go through each steps, okay? So I'm more of making you understand at the same time, so you can get to learn. Now, let's get started. So first, before I get started with this, I need to show you some key concepts about the trigonometric. Let's get started. So if somebody gives you, for example, sine square of angle plus cos square of angle, this is equal to 1. But from this, I can recreate, or I can create a new identity. What does that mean? Let me divide everything by sine square. Each one by sine square. Divide. Okay, divide sine divided by sine is going to give you 1. And then cos square divided by sine square is going to give you cot. And then 1 divided by sine is going to give you cosec. Oh, so from the key identity, we have produce the new identity. Now let's divide everything by cos square. Okay, divide by cos square. Sine divided by cos equal to tan, plus, and then cos divided by cos equal to 1, and then 1 divided by cos is going to give you sec square. So you see, from the key identity, we have produced this identity. So what I'm going to do, I'm going to need this identity. So I can write them aside. I say 1 plus cos square, so I can write here 1 plus cot square equal to cosec. Okay, but I think you can see cosec square. Cosec square, I can say there. Okay, and then tan plus 1 equal to sec. So I can say tan plus 1 equal to sec square, also sec square. But I think you'll be able to see there, or you can remember. Okay, so that one we know. So let's get started now. It's our business. Because you need to know that. And another thing's quick, okay? Question number 2, 3, 4, and 6. This is a trigonometric substitution. How do I know that if it's trigonometric substitution? Whenever you have an integral and then you have a root, if you have a root, you see here there's a root. There's a root. There's a root, and then just know that's an integration. Not all the time, but this is one of the methodology you could have done. Sometimes it could be substitution, but for the most case is Triggy Substitution. Now, how am I gonna know if this is Triggy sec? How am I gonna know this Triggy sine? How am I gonna know this Triggy tan? And how am I gonna know this Triggy sec? Look, if you have stuff like this, or let's say x here minus a square. A can be a number, let's say 3 square, whatever. This, if you start with the x square minus a square, or whichever number is here, this is sec. Then you're going to substitute sec. So how are you going to say? You're going to say this x equal to a, whichever number is here, sec of angle. But what happened when you switch? Means when you start with a number minus x square, and then this is going to be sine when you start with a number. So then when you let whatever is here, for this case is x equal to, take a number which is here with no square, a, and then sine for this case, when you start with a. But now what happened when it's plus? When it's plus, let's say x squared plus a squared, or other way around, let's say a squared plus x squared. These same things, say, take x or x equal to a tan angle. You see? But why does it change? Look, if you start with the x squared, start with the sec. If you start with the a squared, you know, but this can be either way, because look, if somebody gives 2 plus 1 and 1 plus 2 is the same thing, it's going to give you 3. But this is unlike if you say 2 minus 1 and 1 minus 2 is 2 different things. That's what we call 2 different things. Now let's start the first question. So first question has nothing to do with the trig identity, but it's just a normal substitution. I'll show you how to do it. Okay, integral sec x dx. Okay? Now how you do it? So that one, this is easy. So I'm going to do let me check first if it does record, because at the time I was doing some integral and then it was not recording, and then I was almost 1 hour. Now let's go. So now I'm going to do something that's an integral. We still have a sec x here, and then I'm going to introduce something here. I'll say produce sec plus tan, and then I'll write over the same thing. So it's like, this is like if somebody get a over a equal to 1. So it's like I did not produce anything, because like when you can cancel each other, it's going to be sec x is still. So it did not have any effect here. So I produced it for a reason, because back in my mind, I know when I differentiate these two. Okay, now let's multiply that out. So integral multiply is going to be sec x squared plus sec tan. Sec x tan x dx. Denominator is going to be sec x, exactly, tan x. So now, if I let the denominator, let's say u, equal to sec x plus tan x. Now let's differentiate. When you differentiate u, it's going to give you du. So that's going to give us du equal to differentiate sec. When you differentiate sec, you get sec tan. Sec x, tan x. You can just go easily to the differentiating table, which they give to you most of the time. And then equal to, when you differentiate tan, you get sec square. Oh, my pen are getting finished. That's why change. Okay, cool. So then, but look, this is this one right here. Sec square, so sec square plus sec tan x. Sec square plus tan x, dx. So all this half equal to du. I just replace this and plug du. So then I'm going to say, all this question is going to become du. And then instead of writing this on here, sec x plus tan x equal to u. So I can say 1 over u. But now we know, whenever we integrate 1 over function equal to ln. So this is literally say ln of whatever you have here. See, but I will know the value of u. We can substitute that. What the value of u? Value of u, because in the equation, they did give us in terms of x, they did not give us in terms of u. So this time we say equal to ln, I will know the value of u. The reason why I put absolute is because anything which comes out of the absolute, it has to be positive. See, like for example, somebody give ln of -2. This time we say ln of 2 because of the absolute. Otherwise, it was going to say error. Try to plug in the calculator, say ln. -2 is going to say error, but if you plug in absolute mathematical, is that same as +2, not negative anymore, because anything which comes after the absolute is positive. So now we're going to say ln. So we know the value of u. What is the u? Sec x tan x. So it's going to become sec x plus tan x plus c. So this equal to this, which equal to given. So now all these sec x dx equal to this one right here. Ln sec x tan x. Now let's go to the question number 2. So question number 2 is a Triggy substitution. Okay, and is actually sec because it's after the x squared minus a. So that's going to be sec substitution. To be specific, is a Triggy substitution, but it's sec substitution. Okay, now let's go. Oh my god. I was just looking for this one. Okay, question number 2. So I have an integral, and then I have a 1x squared minus 9, and then we got dx. So I'm going to let me let from here. So I'm going to let this x equal 9 means 3 squared. So you take this number here with no square, 3, and then say sec, because you know this is the format of sec. Sec of angle. Differentiate. When you differentiate, this is going to be dx. Okay, right here. Differentiate x, you get dx. Differentiate sec is going to give you sec tan. Okay. So this is going to be sec tan. Sec of angle, tan of angle. D theta. Okay. So what we're going to do, we're going to replace some stuff here because we know most of the stuff. So I'm going to say integral. This is going to become integral now. Dx. What is dx? Dx equal to 3 sec angle tan angle d theta. Now we go here over x squared. X squared means this could be 9 because 3 squared 9 sec square theta. Okay, because now you square this x squared. Okay, now we go square root x squared. What is x? X means it could be 3 square sec square equal 3 square and then minus 3 square. So look, this is going to be 3 tan. You know why? Because let's go there. What is sec? Okay, let me take it back. Sec square minus a number. Sec square minus a number. Look, sec square minus a number equal to tan square. Look, let me just go slowly. So this let me say, but the next one I'll just go automatically. Look, this let me say 9. Okay, and then here's going to be sec square minus 1. We can take 9 out here because this is going to be 9 and 9. Take 9 out, but I still have a root. So we can separate square root of 9 and the square root of sec square minus 1. But what's sec square minus 1? Sec square minus 1 equal to tan square. Take this over. Sec square minus 1 equal to tan square. So this time I say tan square and then square root, and then this is going to be 3. So it's going to be 3 tan of angle. See what I'm saying? So next time what you do, you look at this number. You take this number out and then you focus on it. Sec square minus 1, which is going to be tan square. So this is going to be tan square because it was rooted. Next one, I'm not going to do like all these steps, okay? So now this is going to become integral. See, this is going to be always going to be 3 out. So it's going to be 3 sec theta tan theta d theta, okay, over 3 sec square theta, and this is going to be 3 tan theta. Now we can cancel some of the stuff. Look, 3 go and 3 go. Okay, let's go. 1 sec and 1 sec go. 1 tan go and 1 tan go. So we left with integral. So on top we don't have anything. We have 3, 1 over 3. We can take this behind because this is a constant, so it goes behind the integration. So we left with 1 over, it's just 1 over sec because tan, just 1 over sec d theta. But what is 1 over sec? 1 over sec equal to cos. So this will be 1 over 3 cos integral of cos theta d theta. Okay, so then this is going to become 1 over 3, but when you integrate cos, you get sine. So this is going to be sine theta, and the question is finished. But we're not going to leave the final answer like that because in the question they did not give to us in terms of sine. No, they didn't give us in terms of sine. They give us in terms of x. So what I'm going to do, I'm going to draw a small triangle here. Look, let's assume this small triangle, and this is going to be theta. Now let's come here and focus on this. If this is theta, now we go. Let me take this one. So x equal to 3 sec theta. What is sec? Sec is like 1 over cos. So I can say 1 over cos. So it's like 3 1 over cos. Say 3 1 over cos. So you can say this over 1, and then I'm going to flip it. So this I may say 1 over cos equal to cos over 3. See? And I can literally take 3 here. So it's like say 3 cos theta equal to 3 over x. You see what I'm saying? Or right here I could have just say this is like x over 3 if I don't want to do like this. X over 3 equal to sec. But what is sec? Sec is 1 over cos. So I can flip everything. It's going to be 3 over x. So it's going to become 3 over x equal to cos theta. So when you say cos, mean this is adjacent and this is hypotenuse. So adjacent equal to 3 and hypotenuse equal to x. So for that case now, I can use that small triangle. Look. To get the opposite. How am I going to get opposite? Opposite equal to hypotenuse square minus adjacent square. So it's going to be x square minus 9. See what I'm saying? So, and then after that, I can come to here in my final answer. So my final answer is 1 over 3. Let me check if it does record because some other time I was doing my stuff and then it was not recording. So I'll say this is going to be 1 over 3, but I know sine. How am I going to get sine? Sine equal to opposite over hypotenuse. What is the opposite? That one right there. Over hypotenuse. What is hypotenuse equal to x? So this is our final answer, plus constant c, because we don't have no limits. So the question number 2 is done. Now we go to question number 3. Okay? Let's go to question number 3. Question number 3 is a Triggy Substitution, but it's going to be sine now. So we're going to do the same approach, but this is going to be the sine because it started with a number. So it's going to be sine. If you start with a number square, or because this is like 3 square, and then you do substitution of the sine. But if you start with a variable like the previous one, that you want to just finish now, and then you use sec. Okay, now let's go. So I want to say I can do straight away. So this is going to be let x equal to 3, because this is going to be 9 is like 3 square. So 3, and then we say sine theta. So now you're going to say this is dx, differentiate equal to 3. When you differentiate sine, you get cos theta d theta. Let's replace everything. This question here. Okay, so now we're going to say integral. To replace everything, that's going to be integral, and then we say this one right here. Okay, x. What is x? X equal to this is going to be x squared, means it's going to be this one right here. Yeah, let me do this so I can remember. Okay, x squared means it's going to be 9 sine square theta. Now we have a root. We have a root here. Oh, my pen, I finished, man. I'm very upset now. We have a root. We have a root. Okay, now we go here. 9 minus x squared. X squared means it's going to be 9 square theta. Oh my god. Okay, now we go for what for? Dx. What is dx? Dx equal to 3 cos theta d theta. Woo, my pen, I get it finished, guys. Okay. So now what we're going to do now, we're going to simplify. So this one right here, we know from the identity, because you know the identity, if you have a, this is going to be, okay, look. This is going to be 3 cos. All this is going to be 3 cos. I believe you know that. You know 3 cos. Why? Because look, 9 square root, and then this, because you can say this is square root of 1 minus sine square. Okay, 1 minus sine square equal to cos square, but you have a root cos square. When you square root, you get cos, and then when you square 9 you get 3. So 3 cos. See, because what I did, I take 9 out because 9 over both, and then I separate the root of 9 and the root of 1 minus sine square, and that's what I got. So this is going to be 3 cos, and this is going to be 9 sine square theta integral. Now this is going to be 3 cos theta d theta. So I can just get rid of some of the stuff. I don't need them because I feel like they're useless there. So they just waste my time. So now take all the number behind. 9 times 3, 27, 27 equal to 81. 81 go behind, so we have integral. And now have a cos square and sine square. This is going to be sine square, and this is going to be cos square d theta. So we need to do Triggy double angle to replace some of the stuff here. So from a Triggy double angle, either can replace either sine square has to go or cos square has to go. Especially when you have a cos square sine square, you're going to have to replace with the double angle of the Triggy. So now I'm going to say, personally, I'm going to replace this. Either, it doesn't matter whether this, but I prefer to remove the sine. So what is sine? Sine is like 1 minus cos square. So I can remove this sine square. I can say 1 minus cos square theta. I hope you can see there. Let me see if that pen is visible. If it's not, then I can replace it with another pen. No, another pen is not too clear. So that pen is so fat in a way. So, excuse me, it was integral sine square, but sine square 1 minus cos square. Okay, okay. So what I'm going to do, yeah, 1 minus cos square. So what I'm going to do, oh no. Okay, look. So now we can just, okay, so now we say this is going to be 81 go behind, and this is going to be sine square, and this is going to be cos and cos is going to be cos square d theta. So I can replace one of these two, see? So personally, I don't like to have a sine. So I can say, oh, let me replace sine with the cos. Or I can just replace this stuff in there's a lot of ways you can do. Replace this, man, it's a lot of ways you can do. I can just say, yeah. So this is going to be 1 minus cos square, because say this is 1 minus cos square theta, and then I can multiply that out and say, okay, multiply that out. So this is going to be 81 integral, and put it like this. This is going to be cos square theta, and then d theta, and this is going to be minus cos 4 theta. But when you say 4 theta, d theta is like saying integral of cos theta d theta. But I can replace this same and say cos square. Okay, let me do this. Cos by 4, I can say theta square, and then I can do this for a reason. You're going to see we have 81 outside. Why do that? Because I'm going to have to go to the double angle of cos. We know if somebody give a cos, double angle equal to 2 cos square angle minus 1 from double angle of the Triggy. So if I want to replace cos square, what is cos square? Cos square equal to cos 2 theta plus 1 over 2. It's going to be cos of 2 theta or double angle plus 1 over 2. So I can just replace this. It's going to be 81, and this is going to be integral of cos 2 theta plus 1. This is going to be cos of 2 theta plus 1 over 2. Instead of that, see, I replaced that because I did make subject. This one went over, it become plus, and then divided by these two. So this let me say cos of double, cos of square angle. This one came over here and then divided by these two. So you get cos square of angle, which is cos square of angle. Cos square of angle, and then I have to replace with this. I will write it. So d theta, minus minus. I'll do the same thing here. So this is going to be integral. So I'll replace with everything, which is going to be cos of double angle plus 1 over 2. But for this case, this is going to be square, and then we have our d theta. Let me erase there so we can have a space. Okay, so this one let's erase. So the space here is not going to be enough, so I'm going to have to erase the one on top here. Okay, so we're right here now. So I don't need this, let me just erase, okay? But later I'm going to have to come and use this one here. Let me write here on top so we can remember it's x equal to 3 sine theta. I'm going to have to use this, right? Don't worry about it. Okay, so what I want to do, I have to make a space right here. So this one we're going to have to come and use, right? Let me just raise this on top so we can have enough space here. Okay, cool. Now we go. Let's go, guys. Okay, so what I'm going to do, I can just take this half behind because, look, this is a constant. So this constant can go behind, can be 1 over 2, and then I don't have to write this anymore. Same here. But this one, you're not going to take 2 because this is square, so this is going to be like a 4. So it's going to be square of this, but here is going to be 1 over 4. And here we have a minus, right? 1 over 4. And they have an inner like that. Does that make sense? Oh yes, it makes sense. You see what I'm saying? Was it minus? Of course, yes, it was minus here. Let's see. Inner group that. Was it minus or plus? I kind of forget here. I think it was minus. Let's see. I think it was minus, if I'm not mistaken. But if there's a little mistake, then you can identify that it was minus. I believe so, it was minus here. Okay, cool. Now let's go. So now we're going to say this is going to be 4 because when you square this, is going to be the same thing, square. And on that which has become 4, 4 went out, and then we have our inner. So what we're going to do now, listen, this is easy. So I'm going to say we have an 81, but remember the brackets for both. 81 is outside. So I'm going to say my 81 is outside, and then I can separate. This is going to be inner growth. Look, if somebody gives you inner growth cos of function of x dx, this meaning 1 over differentiate f of x. When you differentiate f of x, it give you prime of x, and then when you differentiate cos, you get sine of x. Sine of x. So that's how you differentiate any trigonometric integration or any type of function of integral. You write the derivative under. So I'm going to say here we have a 1 over 2, and then we integrate. Let's integrate. Okay, cos of 2 theta d theta, because I have to integrate this, the first one. So this is going to be 1 over 2 because you have to differentiate this. 2 theta is going to give you 2, and then when you integrate cos of 2 theta, you get sine double angle. Oh, okay. So this stuff here, when you integrate, give you 1 over 2 sine of 2 angle. So it's going to be, but remember you have a 1 over 2 outside. See what I'm saying? So I'm going to say, okay, I'm going to say 1 over 2, and this is going to be what? But bracket for both. Okay, a half sine theta. Now we want to integrate the second one, because remember this is like this. Half is for both. Okay, integral of 1 d theta. It's like integral of 1 d theta. This is equal to theta. So this is going to give us plus theta. But this half for both. Now we go for the second one. Minus. You see what I'm saying? So then we minus. After we minus, now we say we call for the next one. So for the next one here, we got 1 over 4 outside. But the problem is you cannot integrate until when you expand it. Expand it, okay? So you're going to have to expand this. So now we're going to say, let me just make a space here. So when you expand this is going to be like integral of cos 2 theta square plus 2 cos of 2 theta plus 1. Because you square this, plus 1 bracket d theta. This is for this, like this, and the 1 over 4 out. I hope you understand. So what we're going to do, we're going to say, okay, let me just do this aside here, or I can just, come on man, listen. So I'm going to take this and then I'll integrate aside, because this one is done. So we know when you integrate this one here, it gives us that, sine of theta plus theta. So now let me take this also and integrate aside. So it's going to be 1 over 4. And then will come and plug there. 1 over 4. And then we say cos. So I can just say, let's integrate separate. Cos. Integral of cos. Cos of square. Double angle. D theta. Plus integral of 2. So I can take 2 out. Cos of theta. Theta d theta. And then plus integral of 1 d theta. Like integral of theta. See what I'm saying? So now we know here, this one we know. This is the same as, no, it's not the same, it's not the same, it's not the same. So let's do separate. So it's going to be 1 over 4. So let's keep this slowly. So now, but this one here, okay, very interesting, okay. Let me do this real quick. It's a very long question. It's interesting, okay. Let me start with this one again, okay. So this one here we know from double angle. If somebody give you cos of double of your angle equal to cos 2 cos square of angle plus 1 minus 1. Oh my god, minus 1. Oh my pen was just found. Okay, minus 1. So what we're gonna do for now, look, this is cos of square 2 theta. So it's like it's not square theta for this case. It's gonna be what here? Look, if it's 2 theta, it's going to be square theta. Okay? And if this is going to be 2 cos square, can you see, square 2 theta, means this must be cos of 4 theta. Can't you see? Because if this is square theta, it was from the formula. But if this is square 2 theta, this must be cos 4 theta, and then minus 1. So we're going to place something, because we wanted to place cos square 2 theta. So what is cos square 2 theta? Because you have to come and replace this. Cos square 2 theta equal to 1 come over, it's going to be cos of 4 theta plus 1 over 2. So I'm going to come and replace this stuff with this. You see? So I'm going to say now, this MSA, 1 over 4 is just 1 over 4, and then I'll place everything here, guys, okay? 1 over 4, 1 over 4, because I'm dealing with this. 1 over 4, 1 over 4. And they'll come and replace this stuff. So it's going to be integral. Instead of saying that, I'll say cos 4 theta plus 1 over 2. Let me see if it does record, guys, because I want to make sure everything is visible. Yeah, I believe you can see, but I'm going to have to change the pen, because that pen and the light now is not good. So, and then we say what, D? D theta, okay? So we replace that with this, and then we go plus 2 okay, so let me just make a space here, because I don't need this anymore. Okay, now 2, and then we say 2. Now, when you integrate, this is going to be 1, this 2 over, when you integrate 2, theta is going to give you 2, so right hand is like a 1 over, differentiate 2 theta, get 2. But we have a 2 behind here, so it's like 2 over 2. And then when you integrate cos, you get sine of whichever angle you have there. So this one is done, and then when you integrate, this one you get theta. Oh, so you see now, all this stuff here is getting finished now, okay? So now we say 1 over 4. So all these results I'm going to come and plug in here, okay? Now we say, let's simplify. So now we have to integrate this, and this is going to give us 1 and 1. Now we come here, simplify this. So this is going to be, I can take 2 out, 2 out, okay? Take 2 out, so it's going to be 1 over 4, 1 over 4. And then this one here is going to be 1 over 2 out. And then I have to integrate. When you integrate cos 4 theta, is going to give, I can just do straight away. Okay, integral of cos 4 theta plus 1 d theta. Let me do like that. And then we plus sine 2 theta plus theta. You see what I'm saying? So then what we're going to do now, I can integrate this. So when you integrate this, it's going to give you 1 over, or say 1 over, differentiate 4 theta is going to give you 4. And then when you integrate cos 4 theta, it's going to give you sine 4 theta. Okay? And this one is going to be integral of 1 theta, which is going to give us theta. It's like integral d theta. Because 1 integral of 1 d theta, which is going to give us what? Theta. So here is going to be theta. But all this together is a 1 over 2 for all this, which is going to give us 1 over 8. And this is going to be over 2, and this is going to be 1 over 8. You see? But all of them, we have a 1 over 4. Okay, so 1 over 8. Okay. We have 1 over 4 out, and then we plus, because this is 1 over 4 for both. And then we plus sine. See, this is going to be sine 2 theta plus theta. Now, we can multiply that out, because it has to be 1 over 4 times whatever we have here. So multiply, this is going to be 1 over 32. And this is going to be 1 over 32 sine of 4 theta. And this is going to be 1 over theta over 8. And then this is 1 over 4, because it's just for both 1 over 4. Can you see 1 over 4 times everything? Multiply, this is going to be plus sine 2 theta over 4. And this is going to be theta over 4. Oh, so we know everything which was there. So what we're going to do now, this is going to be written here. And I don't need 1 over 4, because I included 1 over 4 here. See what I'm saying? So now I'm going to do, I'll say, okay, let's plug it in, and let's get finished with the equation now. And then we can say if you have a like terms here, and then the question will be finished now. So the problem was a space here. The problem was space. So finally, this side here is going to be 81 over 2. 81 over 2, 81 over 4. Yeah, 81 over 4. And then plus 81 theta. Oh, 81 over 4. 81 over 4 sine. And then plus 81 theta. Now we come and plug this one here. 81, let's write here like this, 81 theta. And then we minus all this stuff means minus, it must be for all. So we can plug it in, it's going to be minus what? 1 over 32 sine of 4 theta. Okay, this is going to be minus theta over 8. And this is going to be minus sine theta over 4. And then this is also going to be minus because this is minus for all. Minus theta over 4. So what we're going to do, we're going to take all the like terms. What are the like terms? These and these are like term. And these are like term. Means these and these are like term. They all have a theta. In another one, we don't have because sine 4 theta, this sine 4 theta, this sine theta, and this sine 2 theta. So I can just later put this together. 81 minus 1, 81, let's see. Okay, 81 minus 1 over 8 minus 1 over 4. So I can just use my calculator quick. Oh my God, what's my calculator now? Oh, you can write like this, excuse me. You can just say, yeah, let's just put together. It's going to be 81, you can just say like this. 81 theta, let's write first the other stuff. This is going to be 81 over 4 sine of theta, so this is going to be done. And now we go negative 1 over 32 sine of 4 theta. And then we come for this, 1 sine 2 theta over 4. Now I can write the ratio of this stuff. Plus, let me write here, 81 theta, and this one minus theta over 18 minus theta over 4. Stuff like that. You know what I'm saying? So this is a final answer that I can just plug this in the calculator. This is going to be 81 minus 1 over 8. And then I can say minus 1 over 4. 1 4. And this is going to give us 645 over 8. 645 over 8 what? Theta. And this is plus sine 2 theta over 4. And then this is going to be 1 over 32 sine 4 theta. And this is going to be 81 over 4 sine theta minus. Okay, so we finished, but we're not done yet. You know why? Because the final answer, the question given, it was not in terms of theta, it was in terms of x. You know, I still have a little concern. You know what my concern at? There's a place where I say it was positive or minus. So just in case if my answer it kind of deviate from the wherever, you can check it out. And then you have to identify where there was a sign there. That's where you can see if you can do something about it. So now we're gonna say this 32. So I have to come back here. Look, if you have a small triangle like this, and this is theta, this is going to be x over 3. So this is opposite, and this is going to be hypotenuse. So to get adjacent is going to be hypotenuse square, which is going to be 9 minus opposite square. So now we're going to say now, I can place everything here. How? They sine, what is sine? Sine equal to, actually no, I was not supposed to do that. Sine equal to x over 3. So instead of saying this sine, I'm going to say 81 over 4, and then I can say x over 3, and then I can simplify 81x over 12. This is going to be 81x over 12. 81x over 12. Now you come here. Okay, so sine of 4 theta. But the sine of 4 theta, man, also so, okay. Sine of 4 theta I can simplify, okay? By saying, this same is say, sine of 4 theta, come on guys, this is, okay. What if, let's start with this one. Theta equal to, sine inverse of x over 3, x over 3. Oh, so this theta is like saying 645 sine inverse of x over 3. This theta is going to be replaced, and then that's what we're going to have here on the last one. So the problem we have here on a replacement. So this is going to become that, and this is going to become that. So now we come for these 2 here, okay? For these 2 here, so we know the last one, which you have to write. So for a 2 here, the question is done already. This one I have to change in terms of x. But left and right is fine. So I'm going to say this is a double angle. So it's like say 2 sine angle cos of angle. You see what I'm saying? Which is finished already, because look, if I look at my triangle, my small triangle, like I say, this is x opposite and this is hypotenuse. So this is going to be 9 minus x squared. So for that case now, look, what is sine? Sine equals to opposite of adjacent. So I'm going to say 2. So instead of say, oh my God, this one, this is that. It's like sine of double angle equal to. So I'm going to say 2. It's like this one here is like say 2 sine cos sine. But over 4 means this go and this is going to be 2. So I can say everything here over 2. What is sine? Sine equals to opposite over hypotenuse. X over 3. So I can write 3 at the bottom. Okay, now we go cos. What is cos? Cos equal to adjacent, which is 9 minus x squared, over hypotenuse, which is 3 also. So this is going to give us 6, 18. To 1, this is going to be 9. So 1 over 9. Oh, so it's going to be 1 over 9. So this one is going to become 1 over 9x, 9 minus x squared. The middle. So now we count for this one. So we can do the same strategy for this one and get it done. Should I? Now I think you should be able to do. That's going to be your exercise. But if you want to do, then I can do. Then this is going to be your work, because what you're going to do is, okay, 1 over 32, and this is going to be 2 sine of double angle, and then cos of double angle. See, and then you do the same strategy, because sine of double angle, we just got it now. Sine of double angle, we got it now. But cos of double angle, same as say cos of double angle, same as say cos square theta minus 1. And the value of cos we know, like say 2 cos. What is cos? Adjacent over hypotenuse. So it's like 9x squared over hypotenuse equal to 3. But you have to square minus 1, and this is going to be when you square this is going to give you 2 over 9, because this is going to be 9, this 2, and this root is going to disappear. So it's like say 9 minus x squared minus 1. So then everything is going to be term of x. Okay, that's going to mean. Don't forget to plus your c. Now let's go to the question number. This was a very tricky question. Okay, it was big actual. Okay, now let's go to question number 4. Number 4 is not going to be long. Shorter question. Okay, let me use my hand because it's getting dirty a little bit, so I have to use hand to point, so when I solve the next question it can be very clear and clean, you know. Oh my god, just chill. Okay, let's go. I don't have a good wiper, so I have to use some water there. Let's just see. There's a sound of the water bubbling. Okay. Okay, let's go, guys. We go to question number 4. That's a tan substitution. This is a tan substitution. And they'll be finished. Okay, number 4. Okay, cool. So number 4 is easy. So this is tan because there's a plus here. Excuse me, this one. There's a plus here. So same as say integral. Okay, so we have x squared, and then they say x squared plus 9, and then dx. So I'm gonna let x equal to, this is like 3 squared. So I can say 3 tan theta. Let's differentiate. When you differentiate x, you get dx. And then when you differentiate tan, it's going to get sec squared. So let's replace everything. So integral x. What is x? X squared is like 9, because it's going to be 3 squared. 9 tan squared. Dx. What is dx? Dx equal to 3 sec theta d theta. Now we go over. What is x? The value of x equal to 3 squares, like say 3 square tan square plus 3 square here. Because the x equal to this. So square. And then we still have our root. Now we go. So this is easy because I know this is going to be 3 sec square. It's going to be 3 sec. You can just do slowly. You should be able to get an answer. This is going to be 3 sec. So now you can just do trigger here. It's going to be 3 sec because this 3 is going to be 9. Okay, look. 9, but we can separate the root and they say tan plus 1. Okay, this is going to be 3 tan plus 1 equal to sec squared. But you got square root, so it's going to be 3 sec. That's all I'm saying. You see? That's 3 sec. Now we're saying, So it's going to be integral, okay, 9 tan, and then you have 3 here, 3 sec, square theta, d theta. Here is going to be 3 sec. Okay, let's go family. So some of the stuff here they're going to cancel because look, 1 sec and 1 sec go, 3 and 3 go. So we're going to be left with 9, only 9 go out, and then we have integral, and we only left with tan square. So this is going to be tan, excuse me, d theta. Okay, tan square d theta. Oh my god, my pen is getting finished. Okay, tan square d theta. And then we're going to say if you integrate tan, this is going to be, we got 9. But what is tan? Tan meaning, what is tan? Tan equal to, tan square equal to sec square minus 1. So sec square theta minus 1 d theta. I can do like this. Okay, now we go. So this let me say, I can integrate separately. Integral of sec square d theta equal to tan theta. So we have our 9, and this is going to be tan theta minus minus. When you integrate 1 d theta, it's like integral 1 d theta equal to theta. Okay, so this is going to be 9 tan theta minus theta. Okay, so they did not give us in terms of theta. The question was given in terms of x. So I know what is tan theta. Tan theta equal to x over 3 because I can divide by 3 by 3. So tan theta, this let me say 9. But instead of say tan theta, what is tan theta? X over 3 divided by 3, x over 3. So 3 cancels, so it's going to be 3x. Everything's going to be 3x here. 3x and then minus. What is theta? Theta equal to, look, x over 3 equal to tan theta. So theta equal to tan inverse of x over 3. Or you can just say arctan. So you can say tan inverse or you can say arctan. Of what? Of x over 3. And then now you can plus your constant, because we don't have a limit. Now let's go to question number 5. Question number 5 is easy because I'll show you why I say it's easy. So on the question number, which question was this one? Was just trying to be hard a little bit, but we did sort it out. But I'm going to solve it separately another time on its own page, like in its own separate video, maybe after this. So you can learn slowly. Okay, now let's go to question number 5. Question number 5 is easy, so I'm going to say question 5. Oh my god, still wait. Okay. Question number 5, we got integral 1 over c squared minus 6c. So this has nothing to do with substitution, but this is you can do the completing the square. Especially most of these type of question where they give you 1 over quadratic. For the most case, this is you have to do completing the square, and then you do Triggy Substitution. So what does that mean? Let me take this c square and then let's do completing the square. Plus 10. Now when you separate this, it's going to be c square minus 6c, and then let's separate. Write your 10 here. Plus 10. Completing the square. Just in case if you forgot, you can just go back to my other previous video. Say completing the square quadratic, and then you should be able to see this. Now let's go. So take this number here, divide by 2 and then square. So you plus here and then you minus. But the same number divided by 2 and then square. Which number is there for this time? Is -3, but it could be any number. And then divide by 2 that number and then square. And the same thing, you see, let's say plus or minus means it's not going to have any effect in the question. So take the same thing here, just come and plug here. But what you do here, it must be minus, here must be plus, because it's like it did not have any effect in the question. So now this is going to be c squared minus 6c, and then this is going to be plus, this is going to be -3, this is going to be 9. Okay, this is going to be 10, 10 is going to be minus 9. Look, so it's like, make sure you leave a space in between. It's like plus 9 minus 9, so it didn't have any effect in the question. 10 minus 9 equal to 1, so this is like 1. Make sure there's a space in between. So then what you do, if you have to expand it, you have your 1 there. This, let me say, if you want to get c squared must be c and this must be c, how you get 9? This must be 3, must be 3. To get -6 means this must be negative plus 1. So this, let me say, c minus 3 square plus 1. So I can replace that with this. So that's a tricky. Make sure whatever, if you have a 1 over quadratic, change it to completing the square. So that one, I can replace with c minus 3 square and then plus 1. So now what I'm going to do, that's a tan substitution. That's a tan substitution. Because we know when you have a tan, like that's a tan substitution. So how you do, let me explain to you something quick. If you have an integral of 1, and then let's say you have a f of x square plus 1 dx. Oh my god, see my pen get finished, guys. Okay, dx. Then this is tan substitution. So what you do, this could be a, let's say a, because it's not necessarily must be 1, it can be 9, as long as square, or 4. So if it's 9, means it's going to be 3 square. If it's 16, means it's 4 square. So this same as say, take 1 over the number that you have here, is a with no square, and then derivate your function, so write f prime, and then here, say tan inverse. But we know tan inverse, when you say tan inverse of a function, it's the same as say arctan. So either of the two. So I can say arctan or tan inverse is the same thing. Arctan of whatever you have here with no square, and then divide by this number with no square. So if it's in this form with no root, as long as there's a positive here, and they have a square for function and number function. So same here, we're going to do the same thing. This is arctan. So this time is say 1 over our a. What is the a for this case? Is 1. And then derivate your function. When you derivate c minus 3 equal to just a 1. It's going to be equal to 1. Because this is going to be 1, this is going to be 0. So just a 1. And then we say arctan of your function. What is the function? C minus 3. Over our number, which is here, because you must over a. But a for this case is 1. It's like 1. 1 is like 1 square is 1. But you take this one with no square. 1 square. So you take 1 and then plus your constant, because we're going to have a limit. So 1 over 1 equal to 1. Everything's going to be 1 here. So it's like 1 times whatever, it just does something. So there's a final answer. Let's go to the last question. The last question is the substitution for Triggy of sec. Let me see if it does record quick. Yes, it does record. Thank you. So let's go and finish up this question quick. Okay, so the last question is sec substitution. Let's go for that challenge. Very interesting challenge, man. Okay, cool. Now we go. Let me get another pen, guys. I'm running out of the pen. Okay, cool. So now we have an integral, and then r square minus 1, and then we have a root here, and then you have r, and then you have a dr. Okay, so what I'm going to do, this is sec because you have a something square minus 1, and then we have a root. So I'm going to just let r equal to 1, because this is like 1 square. It's like you take whatever numbers here with no square, and then say sec of angle. Differentiate, when you differentiate r, you're going to get, so differentiate is going to be d, r, differentiate this is going to be, when you differentiate sec, you get sec tan. Does it show? Let me see first, because this pen is being faded away, so I don't want to do stuff that you don't want to see. Oh my god, it's not. Okay, can you see? Let me see again. Can you? My god. Okay, cool, let me just finish up. I think you saw that one. Okay, it should have, okay. Sec tan. So now you're going to say now, let's replace back. So I'm going to say integral. My pen not finished. This is going to be the last one, last question, guys. Okay. Integral. So I'm going to say square root r. What is r? R square means it's going to be sec square theta minus 1. You just say 1. dr. What is dr? Dr is sec theta tan theta d theta. Now we over r. What is r? R equal to 1 sec. It's like sec theta. Okay, sec square minus 1 equal to tan square. So this is going to be integral. Tan is just tan, not tan square, because we have a root here. Because this is going to give you tan square theta. Tan square theta is going to give you tan theta. Here you have a sec theta, and here you have a sec theta, tan theta, d theta. Sec theta, go. So here we're going to have integral of tan square theta, d theta. I'll replace tan square theta equal to 1 minus sec square theta. See? So this is going to become equal to integral of 1 of sec square theta minus 1, and then we have a d theta. So we can integrate separate. So this time say, when you integrate sec square, okay, let me just do this. Integral of sec d theta, and then we have minus integral of 1 d theta. 1 d theta is like a d theta. Okay, when you do the sec square, it's going to give you tan theta, and then this is going to be minus theta. Okay. So in a question, they did not give us in term of tan, they give us in term of, look, we know r, which we did let, look, we say r equal to sec, because it's 1 sec. 1 sec is like sec. So now I can replace this stuff because I don't need tan. Okay. Now how I'm gonna change this to tan is easy. Look, I can use this one here. Look, we say tan square. Let me do this. Tan square plus 1 equal to sec square. So meaning, if I want to get tan alone, tan, let me use another pen here. Pen the problem. Tan. Oh my god. Okay. Please. Okay, tan, because we want to get tan, right? Tan equal to square root, because this is going to go over sec square minus 1. Okay, so our tan equal, what is a sec? Sec equal to r. So like say r square minus 1 square root equal to tan. So for that case, I know the value of tan. Okay, so I'm going to say finally equal, what is a tan? Tan equal to r square minus 1. So this is going to be r square minus 1 square root minus, what is that theta? Theta equal to sec inverse. Look, I like this. I love this. Okay, so I'm going to say, look, what is sec? It's like, okay, sec is like 1 over cos equal to 1 over cos equal to r, but this is like over 1. Let's flip everything. So this time I say cos r over 1 equal to cos theta. No, excuse me. Let's flip everything. 1 over r equal to cos theta, because this is going to be, flip everything, cos over 1, and this will be 1 over r. So this is the cos. But here I don't need just cos, I need what? Theta. So what is theta? Theta meaning I can just find the inverse of this. I say, okay, theta equal to cos inverse of what? Of 1 minus r. So for that case now, this is going to be r squared minus 1. And then what is theta? Cos inverse of 1 minus r. The challenge, I accept, we're done. So man, when you have a time, I believe you learn how to do things. I'll try to go fast, but I'll take this question and solve them separately, slowly, for the people who can learn in a slow pace. But you know, that was a challenge, so we get done actually. And thank for time, man. Like I say always, if you wanna, don't feel ashamed, just come subscribe here. You wanna donate on the movement, don't feel shy. You can donate $2, $5, $10, $100. Don't feel shy. You know, I feel shy just a mess. But man, let me donate to that brother, man. He put in the whack. You know, don't feel shy. You can just put it in $200, $500, even $1,000. I'm like, man, this guy is really not shy about donation, you know. So thanks a lot for your time, man. Subscribe, share this video.